We're now going to learn how to solve some of these. So let's look at one that we can just look at and see what the answer would be. So this one's going to be pretty easy to look at. And see what we want. Now what we want is we want both sides to be the same. Okay, so we can look at this one, and just by looking at it, what do you think x could be? Well, what's 3 squared? 3 squared is 9, right? Okay. When we solve these, we want to make sure that our bases are the same. That way our exponentials are solvable. So it gives us our equation. So we know then, and we know now that 3 squared is 9, right? So we can actually rewrite this as 9 to be 3 squared. Okay? And we already know the answer, but this one's a very simple one. I just want us to see the procedure. Now, when I rewrote that 9 as that 3 squared, the bases, the numbers down below, are the same. Okay? So since the bases are the same, then our equation can be solved, and that would simply be x equals 2. Because that makes it the same. Because we know that 3 squared is what? 3 squared is 9. Let's try another one. So we're going to try another one here. We're going to try and solve this one. And what we want to do is we want to transform that 125 into a power of 5. Well, we know that 5 cubed is what? 5 cubed is 125. Right? So I can rewrite this as 5 to the x minus 4 power equals now 5 cubed. Okay? And what do we now know? Well, now we've rewritten it. So the bases, the numbers down below, are the same. And since the bases are the same, then the exponents, the number on the top, need to be the same as well. So what does our equation now become? Well, it now becomes x minus 4 equals 3. We can add 4 to each side, and that leaves us then with x equaling what? X equaling 7. And that's what we want. We want to make sure that these bases are the same so we can get the same exponents. And in some cases, you may need to make sure that the exponents are the same so you can get the same base. We'll talk about those here in a moment. Let's try another one. Okay, well, we're going to try and do the same procedure on this one. And again, we're trying easier numbers first, and then we'll go on to some more difficult ones. But this one we can look at, and we can see that 7 to what power is 49. We know that 7 squared is 49. Okay, so that means our common base is going to be that 7. So then we rewrite this as 7 to the 3 x minus 5 power. And that 49 is 7 squared. So that becomes 7 now to the 2x power. What do we know? We know that the bases are the what? Same. So then the exponents must be the same. So what does our equation become? It becomes 3 times x minus 5 equals that 2x, doesn't it? Distribute that 3 through. And now we've got something that we can work with. So we've got 3x minus 15 equals 2x. We'll move that 3x over. Shouldn't have any trouble solving these once we've got the bases the same. So that leaves us then with a minus x equals a minus 15. Divide by your negative 1, and that gives us then x equals now what? X equals now 15. Let's now look at a fraction one. And we're going to need to remember our rule for negative exponents. So let's try and solve this one. By getting the bases to be the same. And this one's pretty easy to look at and to work through. Now remember our rule for negative exponents. Our negative exponent rule says a to the negative n is 1 over a to the n power, right? Okay, so using that rule, we can write this 1/2 as 2 to the negative first power, right? Because you can flip it over. Whenever you flip something over, it becomes a negative exponent. And that's what we want. Okay, we want to make sure those bases are the same. So now what we have is we have 2 to the 3x minus 5 power equals 2, and we have a minus 1 on top, and that's going to be multiplied by x minus 1. So you see how I rewrote that fraction. When you flip the fraction over, it changes that exponent. Now the bases are the same again, and since the bases are the same, we know that the exponents must also be the same. So now we've got our equation. 3x minus 5 equals minus 1, parentheses, x minus 1. And we can solve it by using our distributive property. And that gives you a minus x plus 1. And we'll move things around, so I'm going to add that x over. And I'm going to add that 5 over as well. So that leaves us then with 4x when we add here. And 1 plus 5 makes it a 6. Divide by your 4 and reduce it down. And x is now 3/2. When we reduce. So do you see how we got those bases the same on that? Here's another one to look at. Let's try and look at this one. This one's a little bit more complicated. And so we need to think about how we can make this one work. And you can change either side that you want. But let's look at what we've got. Okay, so we want to see how we can change these to have the same base. It's usually easier to get the smaller base. So what do we know about 4? Well, we know that 4 squared is what? 16. And we know that 5 squared is 25. Those are going to match up with this one. But what do you notice about this one here? Well, the 4 is in the numerator on this one, and the 16 that it matches up with below is in the denominator. So we need to flip that fraction over. So we can take that 25 over 16, And we can now write that as 4 over 5 to the negative second power. Because we had to flip it over, right? So that made it negative. And what do we know about 4? Well, 4 squared is going to be what? 4 squared is 16. And what about that 25? 25 squared is what? 25 squared is that 5. So we need to flip it over so it matches. And then look at our powers. So now we can rewrite this with our common base as 4 over 5 to the x minus 6 power. And this we're going to rewrite as 4 over 5 to the negative second power. Are the bases the same? Yes, they are. If the bases are the same, then the exponents must be the same as well. So our equation is then simply x minus 6 equals a minus 2. Easy to solve. We'll add our 6 over. And that leaves us now with x equaling 4. Okay. So let's look at another one. I'm going to pick some from our textbook here. And this is in chapter 4, I believe. Systems are in 5. These are going to be out of 4. So I'll just pick a few from our textbook to work through using these exponents. If you don't have your textbook with you, that's fine. So I'll just write them up here. Let me find a couple of these to work through. Get in the right place here. These are going to be out of 4-1. Okay, find a couple of these to work through here. Or I can make up some more, but I'd rather just pick some from the textbook if we can. 4-1 is inverses. 4-2 is exponentials. Let me find a couple of these to look at. Okay. So let's try and see how we can solve. Oh, let's look at some easier ones here. This one's a little bit different too. How about we look at this one? And this, if you want to look in your textbook, if you don't, that's fine. I'll write it up. This is going to be on page 460. We're going to look now at question 79. And for question 79, we've got 27 to the 4x power equals 9 to the x plus 1 power. Now, this one is going to be a little bit different because we can't just use the smaller number and make it a power of a larger one, because 9 squared would be 81, and we don't want 81, we want 27. So what we can do, though, is we can break them down, because 27 and 9 are both powers of 3. We want a common base at some point. So we can rewrite this now as this. We know 27 is 3 cubed. And we know 9 is 3 squared, right? Okay, are you okay with that so far? Because yep, 3 cubed is at 27. Or sorry, no, yeah, 3 cubed is 27. And 3 squared is 9. So now we can rewrite both of them. Our common base is going to be a 3. So we can take this 27, and we can write that as 3 cubed. Now, the exponents on the top are going to multiply together. So you just bring that 4x down with it. And then what about the 9? Well, 9 is 3 squared. Now we have a common base, don't we? Common base is a 3. You have to have a common base. Since the exponents, or sorry, since the bases are the same, Then the exponents must be the same. So 4 times 3 makes it a 12x. And what is that going to equal? That's going to equal 2 times x plus 1. And we can solve this by distributing the 2 through. And that leaves you then with 2x plus 2. And the other side is a 12x. Move that 2x over. And that gives you 10x equals 2. Divide by your 10 and make sure you reduce. And that reduces down to now be x equals 1/5, doesn't it? So that's how we would solve that. So we have to get a common base. So this one is a little bit different from the others, but that gives us the common base that we're looking for. Okay, let's see how we would look at question let's see. How about we look at question 82? So let's look at question 82 now. And this one again is similar to what we've done before. We've got a 2 to the 6 minus 3x power equals 8 to the x plus 1 power. Okay, this one we're not going to have to change them both. We only have to change the larger one because we know that 2 cubed is 8, right? So you always have to get that common base. So you look at the numbers and you see what they have in common. They may have a common power, like the last one, right? On the last one, we had a 27 and 9, so we had to break them into threes. This one, we know that 2 cubed is 8. So we can now write this as 2 to the 6 minus 3x power. We know 8 is 2 cubed. And bring that up to the top. And now what can we do? Well, now the bases are the same. So then the exponents are the same. So that makes it then a 6 minus 3x equals 3 parentheses, or sorry, not 3, yep, 3 parentheses x plus 1. We'll distribute that 3 through, and that gives you 3x plus 3. The other side is a 6 minus 3x. Move it around, so move that 3x over, and move that 6 over also. The 6's will cancel. That'll make it minus 6x on the left. On the right, we have 3 minus 6. Makes it a minus 3. Divide by your negative 6. Negative and negative makes it then a positive 1/2, doesn't it? See how we distributed through there? Okay. And that was question 82. If you want to look in your textbook, that's fine. I'm just writing down some different sample problems. And then once we get these down, then we'll look at the 3 on our practice fund. So these have all been when we make the bases the same. In some cases, we may have to rewrite them so that the exponents are the same. So let's look now at question number, let's do 86. So question 86. This one's kind of the opposite. We need to make sure that our exponents are the same to get the common base. So we have x to the 3/2 power equals that 27. Oops, we need to come up with a common base here. Okay, so how do we do this one? Well, if we look at this one, again, we want a common base to solve it out. And what do we know about 27? Well, if we think about our powers, and they're going to be smaller numbers, we know that 3 cubed is what? 3 cubed is 27. So we're going to have to rewrite this one a couple of steps just to make it work. So now we know x to the 3/2 power equals 3 cubed. We're almost there. And we need to make sure that we get the same exponents because we want the exponents to be the same so we can get our bases. Well, what do we know about, we got our numerator the same, we need to get our denominator the same. So if we look at our numerator, that's taken care of. And so that was what we needed there. Now what about the denominator? Well, that denominator is a 2. And what do we know about 3 squared? 3 squared is 9. So we can now write this as x to the 3/2 power equals 9 to the 3/2 power. And so we'll do several of these so you see how we get those fractional powers to be the same. What do we now know? Are the bases the same? No, but the exponents are, right? And if the exponents are the same, then the bases have to be the same. So this has to come out to be x equaling now what? 9. Okay, and that was question 86. Let's go back and look at 85, just to make sure we have these down. Okay, so question 85 is x to the 5/2 power equals 32. So the first thing we look at is we look at this 5. So let's see what we can use and raise it to the 5th power to make it 32, because we're kind of doing the opposite of what we did a minute ago. We want the tops to be the same, and then we'll deal with the denominators. So what do we know? Well, 2, because 2 to the 5th power is what? 32. So we can rewrite this now as this. How do we get rid of that 2? How do we make that fraction the same? Well, we know that 2 squared is what? 4, because that's what's down below. We want the number down below to be the same as well. So we can now write this as x to the 5/2 power equals 4 to the 5/2 power. So we know then that x has to equal what? X has to equal 4. So those are a little bit difficult. You got to think about how the powers work, how they go together, what you can do with them. So let's look at, let's see what we can do with question 88. Sure,
So this the final or next week?
No, week after, May 12th. Okay, everything has to be turned in when class starts on May 12th. So on May 12th, you need to make sure all of your homework is turned in. So when you back homework, make sure all your exams are graded, or turned in, I mean, for me to grade. And then you'll also want to make sure you turn in the practice final. You'll get 20 points for working that out. You've got the key, but at least try and work it on your own. If you work it out and I see work, you'll get the 20 points. Make sure you bring back that take-home final because that's going to be graded. We'll come to class on the 12th. Just like all the other exams, you can have either a page of notes or note cards. And we'll take our exam then not next week, but the week after. Next week, we're going to work on logarithms. Yep, in my mail. Yep, they're in the mailbox there, so you want to make sure you take those sometime when the college is open.
Thank you.
You're welcome. No problem, not a problem at all. And like I say, you can watch the video later on if you need to as well. Okay, so let's look at another one of these. This one's a little bit different. Let's look at 87. So question 87. we've got x to the negative 6th power equals 1 over 64. Well, we want to get a common exponent. So first thing we can do is we can rewrite this 1 over 64 as 64 to the negative 1st power. So we're getting closer here. Now, what else can we do? Well, we need to now look at that 64. And we need to figure out what number raised to the 6th power is going to give you 64. Well, what about 2? Because you can use your calculator if you need to. Use the caret key. What about 2? Okay, 2 raised to the 6th power. What does that give you? 64. And that's what we want, right? So we can now use the 2 here. So that gives us then x to the negative 6th equals 2 to the negative 6th power. Okay, we flipped it over so it became negative. That was our first step. So these are the same. And then we try to figure out our exponent. And we know just by working with the numbers, they're going to be smaller numbers. And we know that 2 raised to the 6th power is our 64. And since the exponents are the same, bases must be the same as well. So that simply means that x is going to equal now what? X equals now 2. Okay. Look on another one of these. Let's try a different one here. How about question 96? Same concept again. So we're going to look out question 96 here. Same process of working with it. Well, first thing I want to do is get rid of that fraction. So we know that 1 over 32 is 32 to the negative 1st power. And 2 is used a lot because 2 is easy to take powers of. What number again, raised to the 5th power this time, is 32. So that one's pretty easy to see. That would be a 2 again. So that means we can rewrite this as 2 to the negative 5th power equals x to the negative 5th power. And we now know that x must be what? X must be 2. Okay. Let's go ahead now and look at some questions on our practice fund. And I may let you out a little bit early because we'll save the logarithms for next week. So let's look at our practice final. And we'll do those 35, 36, and 37. Make sure we can get these to work here. All right, so let's look now at question 35. And this is on your practice final. And we've got 3 to the 10 minus 2x power. We want that to equal 729. So where's our variable at? Our variable is up in the power. So that means we want the bases to be the same. Now, what common base do you think we're going to use? Well, the smaller one is a 3. So let's see if we can figure out what 3 raised to will give me 729. And we'll just use our calculator to find that value. Okay, we're going to start with 3 squared. 3 squared is obviously not going to work, because 3 squared is 9, right? Not going to work. What about 3 cubed? 3 cubed is 27. Doesn't work. 3 to the 4th, 81. Get closer. How about 3 to the 5th power? 3 to the 5th power is 243. How about 3 to the 6th power? 729. You see how I just worked it out? So you know what base you're going to be using because you look at the smaller number and you can't break 3 down. 3 is not going to break down. Had it been something like a 25, you'd have to rewrite it first as 5 squared. 3 can't be broken down. So then it's just a matter of figuring out 3 raised to what power is that 629? And that's a 6. So now we can rewrite this as 3 to the 10 minus 2x power, and that's going to equal 3 to the 6th. Most of the work is done. The bases are the same. So if the bases are the same, then what do we know about the exponents? They have to be the same as well, and we can solve it out. So that means our equation becomes 10 minus 2x equals the 6. Move that 10 over. So then minus 2x equals now minus 4. Divide by our negative 2. And that leaves us then with x equaling, when we divide, 2. So these aren't that difficult either. Let's look at 36. 36, we're going to have to transform both of these. Because if we just try the smaller one, well, 16 squared is 256. And that's not going to work for us because it's way too big. But what we can do is we can take the 16 and we can either break it up into 2s or we can break it up into 4s. Well, 16 is 4 squared, right? Okay, we can use either a base of 2 or a base of 4. What about 64? Well, what about 4? If we use a common base of 4, 4 cubed is what? 64. So we know 64 is 4 cubed, 16 is 4 squared. So we can now rewrite this as 4 to the 2nd power times x minus 1. Or sorry, 3rd power. It should be 3 there because it's 64. The other one is the 16, so that's going to be 4 to the 2, and multiply that by the 3x power there. You see how I got the common basis? Is it making sense with those? And these are not difficult. They're nice, easy things to end with. As long as you see the pattern, you just got to find the numbers that make it work. Now the exponents, or sorry, the bases are the same, so the exponents must be the same as well. And we know that 3 times 2 makes it that 6x. We can solve it by distributing our 3 through again. So that's 3x minus 3 equals our 6x. Move that 3x over. And minus 3 equals positive 3x. Divide by our 3. And we now have our answer to be a negative 1. Okay. Let's look at the last question here, see if we can remember how this one will work. So what we've got is we've got 2 to the 5 plus 3x power equals 1 over 16. And we've done several of these already. So what do we do first? Well, get rid of the fraction. And we know 1 over 16 is 16 to the negative 1st power. And let's find our base here. Use a base of 2. 2 raised to what power makes it 16? 2 squared is 4, right? 2 cubed is 8. So 2 to the 4th power is what? 16. So we can rewrite this as a 2 to the negative 4th power. Why is it negative? because we had to flip it over, didn't we? So that's why that piece is negative. And then we figured out that 2 to the 4th was 16. Now the bases again are the same. And so the exponents must be the same as well. So 5 plus 3x equals that negative 4. And easy enough to solve. Move that 5 over. So 3x equals negative 9. Divide by our 3. And x now equals negative 3, doesn't it? Next week when we come into class, we can go over any questions that you might have on that practice final. You've got the key, so you can look and see how they're done. But any of you want me to go over in more detail, we can do that. And what we're going to look at next week is we'll go over any questions on the practice final that we need to. And then we're also going to look at the last 3 questions, which are logarithms.